In developing computer applications, much of the processing involves doing mathematical calculations. And in this video, we're going to explore the basic operators in terms of working with math. There's a math class in addition to this that gives us access to much more advanced type mathematical procedures, such as working with sine and cosine and tangent, generating random numbers, and so forth. And we'll look at that soon in a future video. The simplest mathematical calculation that we probably all learned as elementary school students was addition. And the operator for doing addition calculations in both Visual Basic and C# is the traditional plus sign. And so in this example here, I've got a variable x which will hold a double value or a floating point or decimal value. And x equals 5.7 plus 3.2, and then I use a message box statement to show the value of x. And we see the example there in the message box is 8.9. 5 plus 7 plus 3.2 is 8.9. In the same way, the subtraction is, of course, the minus sign, or some people might refer to this as a hyphen. And here I'm subtracting 3.2 from 5.7, basically the same statements otherwise. And our result is 2.5 as shown in the message box. In your grade school and high school math classes, you might have used an X as the multiplication symbol or a dot, maybe in algebra. In computer programming, it's the asterisk. That is a shift 8, sometimes referred to as the star. So here, as an example, I've got X dimmed as an integer value, and X equals 8.7. And I show that in the message string, and the result is 56. And division, we have a /. And division's a little bit tricky, especially on the C# side. And there's actually 3 different division operations. This is the normal, regular division. And so on Visual Basic, I can divide 10 by 3, and the result will be 3.333. And you see it extends pretty far out there as far as the number of decimals because this is a double value. If I dimmed x as single, it would be considerably less. And on the C# side, the same thing, except you'll notice that I put 10.0 divided by 3.0. And that's because x is a double here. I want to make this a regular division with a decimal point value. And by specifying one of those literal numbers as a decimal value, I will get the same result. And that's where the difference kind of comes in. It makes it a little tricky for division because we also have what's called integer division. And in VB, we're using a backslash instead of a /. So in VB, if I divide 10 by 3, make it an integer division operation, the result is not 3.333. The result is 3. And what's happening in an integer division is the remainder is dropped. And you can see over there on the right that in a traditional math class, 3 goes into 10 3 times, and we have 1 left over. We drop that 1, and that 3 is the result. Now on the C# side, it simply defaults to an integer division using the normal / operator if both the dividend and the divisor are integer values. So you can see I don't have 10.0 or 3.0, I simply have 10 divided by 3, and in that case it's going to give me an integer division. So in C# it really depends on what's being divided and what it's being divided by. If either one of those has a decimal point, we will get a decimal point in our answer. Now there's a third type of division operation, and that's called a modulus operation. And it's sort of the opposite of integer division, in that in my Visual Basic example here, I've got 10 mod 3. So mod is the modulus operator. And what it's going to return is the remainder of an integer division. So we saw earlier 3 goes into 10 3 times, and there's 1 left over. Well, the result of the mod operation is that 1, that remainder. And on the C# side, rather than using mod, we use a % sign. So 10% 3 is going to give us 1. Exponentiation operations with VB are performed using a caret or a shift 6. And so here I have x equals 5 caret 2, or 5 raised to the power 2, or traditionally you might say 5 squared. And so the result there is 25. Now we don't have an operator on C#, but there is a method in the math class. And as I said, we'll look at the math class down the road a little bit here. But on the C# side, to do the same thing, it would be x equals math, that's the name of the class, .pow, that's the name of the method. And then inside parentheses, I have two values, 5, 2. So the first number there is the number that is being raised, and the 2, or the second number, is the exponent. And again, the answer would be 25. Now, a lot of times in doing calculations, we're going to combine operators. And so in the Visual Basic example here, I have x equals 5 plus 4 times 3 raised to the power of 2. And the same thing written in the C# side. 5 plus 4 times 3 raised to the power of 2. What I'd like you to do is just pause the video here for a second and see if you can calculate what that answer should be. And the correct answer is 41. You might have thought 5 plus 4 is 9 times 3 raised to the power of 2, which is 9, so 9 times 9 is 81. Or you might have thought, well, we'll take 5 plus 4 is 9 times 3 is 27. If I square that, the answer is 729. But the correct answer is 41, and here's why. There's an order of precedence that comes into play when we do mathematical calculations. And exponentiation is always performed before the other operators. So the first thing I would do here is take 3 raised to the power of 2 is 9. And then multiplication is done before addition. So I now have 5 plus 4 times 9. Well, I take the 4 times 9 is 36. And then the 36 plus 5 is 41. And we get the same result on both sides, whether we're using VB or C#. Here's a table that shows that order of operations. So parentheses override all operations, and we'll look at that as an example here in a minute. The first thing that takes place outside the parentheses is any exponentiation calculations, and then we would do any multiplication or division operations moving from left to right, and then any integer division, and then any modulus, and then addition or subtraction, again moving left to right. On the C# side, since we don't have an exponentiation operator, it's going to be multiplication, division, and modulus operations that all take precedence, again going from left to right, and then any addition going from left to right, and parentheses, of course, can override all of that. So in the next example here, I've got that same expression, but I've added some parentheses. And so we're going to work with the parentheses from the inner set to the outer set first. So my inner set of parentheses here is 5 plus 4. Well, 5 plus 4 is 9. And then my next set of parentheses is that value times 3. So I have 9 times 3. That's going to give me 27. And then the final operation is that exponentiation, which is 27 raised to the power of 2, and my result is 729. I've written it in the same way using C#, in which I'm doing the calculations first of 5 plus 4 times 3, and then that value is used inside of a Pow method. So we're going to get 27 basic comma 2 inside that power, 27 squared, 729. Now we can also use what's called unary assignment operators. So I might have x equals x plus 15, or I'm going to add 15 to the value of x. And programmers like to write that in an abbreviated way. We like to do less typing. And so often you'll see it used as x plus equals 15. And what that means is simply take the value of x and add 15 to it. It's called a unary operator because there's only one value on the right side of the equation. By the way, you always write these equations with the expression on the right, and it's being placed into some value or some container that's listed on the left. It's never the other way around. Unlike when you did algebra, you could probably have this written either way. You could say 5 plus 4 equals x as an example. Or in this case, x plus 15 equals x. That would not be accepted by the computer. So it's whatever's on the right is calculated, and it's assigned to the value that's on the left. There's other unary assignment operators. So we saw plus equals. There's also a minus equals. There's a multiplication equals or star equals. Then there's a division equals and an integer division equals on the VB side. And on C#, since we don't have a operator for integer division, there's not integer division equals on the C#, but there is a modulus equals on the C#. So if you look at the division symbol there, the example would be x / equals 5 is the same as x equals x divided by 5. So in this example, if x had a value of 15, once that statement is ran, x would now have a value of 3. And it's important to note that mathematical calculations can involve not just little numbers, but also variables. And in fact, it's more often probably to involve variables, because we're just using little numbers. We would just calculate those and plug those right into our code. In most cases, we're going to read values in from a text box or an input box or some other source, place those into a variable, and then do mathematical calculations on the values of those variables. So in this example here, I've got x, y, z, and sum, which are all integer variables, and I've set x equal to a value of 5 and y to a 3, and then for z is going to equal whatever the value of x is times 4. So z in this case would equal 20. And then I've got sum equals, in this case, everything on the right are variables. So sum equals x plus y plus z. So x in this case, or sum in this case, would equal 28. And then you see the same thing written there in C#. And those are the basic mathematical calculations or basic mathematical operators. And we'll look at the math class here in a little bit.